So while the topic is primarily around sharing, yeah, um, sharing the benefits of wood plastic composite in helping India achieve its carbon neutrality goals, I will extend that subject to all the natural fiber composites, which can be classified together as biocomposites. Firstly, myself, I'm Mahadev Chikkanna. I'm the CEO and founder of Spectlalite. I think it's already been introduced. At Spectlalite, we source natural fibers from either farm, forest, or factories, which includes different crop residues. We started working with bamboo fibers, then subsequently wood, rice husk, and we are pretty much agnostic across lignocellulosic fibers currently. We manufacture biocomposites out of these for different applications and help our customers convert them into finished products. We've also developed our blockchain-based solution, which helps in creating trust around our products. That helps to provide provenance and stewardship of resources. It also helps in capturing the carbon footprint of our products that we deliver to our customers. India's aspiration for carbon neutrality by 2070, Mr. Modi has committed to certain very ambitious goals in COP26 that was held recently. As on 2020, India's carbon emission is about 2.88 gigatons. And by 2030, our commitment is to reduce our intended carbon footprint by 1 gigatons, which means the intended carbon footprint of India is expected to be about 3.9 gigatons, and they would contain it down to 2.8, 2.9 gigatons. So the idea is to reduce the carbon footprint increase that would eventually happen in the next 10 years to contain it by about 1 gigatons. So we have to demonstrate that through the actions, whether it is conversion of energy from coal into renewable energy, or transportation from ignition engine to, let's say, electric vehicles. So through all this combined effort, it is required to demonstrate that we have reduced 1 gigatons of carbon emission by 2030. It's a very ambitious target because India is an emerging country, which means, and the population is continuing to grow. That means we will continue to increase more activities, industrial activities, service-oriented activities, manufacturing of products. And if India has to achieve the 5 trillion economy mark as well, that will result in significant increase in carbon footprint to really think about it. But if we have to contain this by about 1 gigaton, that's already a massive aspiration for an emerging country like India. There is simply no other country which has made such bold statements. And that really makes India a very proud nation, stands out in the global map, at least when it comes to climate action. By 2070, India is expected to hit carbon net zero, which means all the activities combined, whether it is industrial, consumer, energy, transportation, the net release of carbon into the atmosphere as a result of activities within India will not be will be zero or less than that value. So very aspirational goal again for a country like India, which is increasing its population and continuing to grow its economy. But this is a much need of the hour. There are a few other countries such as certain Scandinavian countries in Europe who committed to hit the carbon zero in before 2050 itself, which is okay for a developed country where the requirements are pretty much saturated. But for an emerging country like ours, it's a massive task to achieve. The only other countries which are already carbon zero are such as Bhutan, where their forest cover is much broader. I mean, much wider, and their economic activities are not as significant as some of the other economies outside Bhutan, and as a result of which they're already a carbon zero country. Now, some of the volumes to consider as well. India is estimated to produce or generate about 500 million tons of crop waste every year. Mr. Rathod sir talked about the plastic waste, which is also significant, which will be in the order of about 2.3 to 3.5 million tons. But the crop waste that is generated in India is well over 500 million tons, metric tons. And can we put to use? Because that's a fantastic resource which has got biogenic carbon in it. And one of the most used application for these crop residue today is to convert them into energy, mostly thermal energy, displacing coal primarily. Um, then there is about 15 metric tons of fresh plastics that are consumed in India. This is besides plastics that are manufactured and exported, right? That's a significant amount. Obviously, we can't displace all of the plastics with something like crop waste or wood polymer composites or biocomposites as we speak. And the capacity for the displacement also will not utilize the entire crop residue that we have, that is 500 million metric tons. This is expected to grow to about 15 million metric tons by 2030. Again, this is as a result of increase in consumerism, increase in economic activity, and then increase in population as well, right? So this whole plastic consumption has been growing much more significantly in India than anywhere else as we speak. So these are sub numbers. The question is, can we displace this 50 million metric tons of plastic, which would otherwise be used by 2030, with something that is more novel, such as biocomposites? And what would its effect be on climate action and our target for meeting carbon emission goals, right? So that's something that I'll be covering, right? So in order to do that, before that, I think as a basic fundamentals of what biocomposites are, it's just bringing together polymers and biomass into a matrix that can be used for either replacing wood or replacing plastic. In most of our application or discussion currently, we will discuss primarily its utility to replace plastic more than replacing wood. However, there are benefits of replacing wood with bioplastics, especially if it can be accounted to deforestation and change in land use. There is definite advantage in doing that as well. However, if wood is already sourced from sustainable forestry, which is accounting for regrowth and regeneration for the period that these products are utilized, it could still be a challenge in terms of matching the carbon benefits associated with that. But we have credible and clear statistics associated with how bioplastics or wood plastic composites would benefit the planet in general as a result of replacing plastics. For us to understand what the benefits are, we need to have a life cycle analysis framework. And a simple framework is to have an inventory of LCI database. And we have captured the inventory from one of the open source master data that's available for understanding the different carbon footprints of various materials that are used, including the regular plastics, bamboo, wood, and so on and so forth. Then we have to account for biocomposite manufacturing related energy consumption, renewable material and its sources, binders, additives and their sources, and then finally input related to transport and raw materials, transport of raw materials and finished goods. So we have to take all of this into account while assessing the life cycle impact. Although life cycle impact is assessment is done for different environmental factors, in this discussion we will be only looking at the carbon emission and the climate action only. Okay.